we're gonna look at a rate of change in the limits. Yeah, that's what we're gonna talk about first. And well, I mean, to introduce this topic, we'll first start talking about average speed and instantaneous speed. So let's think about what that is. The average speed of like a particle or any object would be the distance divided by the time it takes to travel that distance. So that's the elapsed time. So you would need a starting spot, which usually will be 0. The distance would be 0, and then how far it went, and then here you would have two time intervals. Or two time values when you started and when you ended. Usually 0 to something as well. So let's look real quick. What is an example of this? Holy Jeebus, that's a lot of writing. If a ball is dropped from some distance above the ground, its distance from its starting point can be modeled by y equals 16t squared, where y is in feet and t is in seconds. What is the average speed during the first 2 seconds of fall? You could probably figure this out just with the definition of average speed. So we got to figure out, first of all, the time, which would be 0 to 2. So the change in time would be 2. And then we got to figure out the change in distance. So we got to know the starting point. Well, if we plug in 0 for t, we get 0. So let's write this out. So average speed. So if we plugged in 0, we would get 0. So it starts out at 0. If we plug in 2, we get 4 right there. 4 times 16, that's 64. So 64 feet. It falls. It is 64 feet from where it started at 2 seconds, at exactly 2 seconds. So we can go 64 minus 0, that's the feet, the ending position of the ball at 2 seconds, and then I can go 2 minus 0. So I'm just cutting it in half, which is 32. This is in feet, this is in seconds, so I would have feet per second. So that's the average speed over the first 2 seconds, during the first 2 seconds. It doesn't mean it's traveling this fast at 2 seconds. It means all total, that's how fast it was traveling on average. Now suppose we want to find the instantaneous speed at t equals 2. Now we can kind of generalize this formula, not generalize, but we can kind of tweak the formula so that it gives us an idea of what an instantaneous speed would be. So instantaneous speed. So how would we go and figure out that? Well, the idea behind this is, what if we just chose some really small time interval around 2. So it's kind of still an average speed, but the time interval is going to be really small. So we're going to get the average speed from t equals 2 to like maybe t equals 2.1. And so that's still really small. It's an average speed from t equals 2 to 2.1, but it's almost close to 2. So that's the way we can write this out. Let's see. The way we can write this out, instead of evaluating from 0 to 2, from 0 to, so t equals 0 to t equals 2, what we're going to do is evaluate this from something smaller. So from t equals 2 to t plus some really tiny number. So this, we're going to get the average speed in this time interval where h is some really small number. So we can calculate the change in distance, right? Because that's distance divided by time for average speed, and this is still average speed. This is where the idea of a limit comes in. If we let t go to 0, then it'll become instantaneous speed. But we suppose we don't know what limits are yet. So let's rewrite this. I'm going to do the same thing up here. So what is if t plus h? H is something that's going to be really, really small. So, well, first I'll take the time interval on the bottom. So I know one of my t values is t equals 2. And then my second t value, maybe that'll be t1, t2. My second value is 2, yes. 2 plus h, where h is really, really tiny. So if I take 2 plus h, that's my first t, subtract 2, that's going to be my change in time. So what's the change in the distance? That's fairly simple. All I need to do is figure out the distance the distance away from where it started when t equals 2. That's just plugging in 2 to this formula, so I'll do that. And we already did that, actually. That's 64, right? And then I'm going to subtract. Oh, no. I got to do it in the correct order. I wrote this one first here, so I have to plug that in first. So what's that? 16 times, I'm not going to do it in red. 16 times 2 plus h, quantity squared. I'm just plugging 2 plus h into this formula. And then I'm subtracting, because this represents the position, the distance from where it started when t equals a tiny bit more than 2. A tiny bit more than 2. And then I'm subtracting off the distance when t actually equals 2, which is 16 times 2 squared. So that's 64. So let's simplify this stuff, and let's see what happens. First thing I think of is I can FOIL this out. What would that be? 16 times 4 plus 2h plus h squared. And then minus, again, this would be 64. It's because 4 times 16. All over, we don't need these parentheses there because there's nothing to distribute or no exponent. So that 2 cancels out with that 2, and I'm just left with h. Just kidding, this would be 4, right? 4h, I think. I'd have to 2 times 2 is 4. 2 times h is 2h, yeah. And then h times 2 is 2h. Okay, so this would be the average speed for something where h is really, really tiny. And then I'm going to continue to simplify it. So I'll distribute in combined like terms. So now I have something like this where 64 and negative 64 cancel out, and everything has an h, right? But I can factor out an h. So I'll divide by, well, I'll factor out an h in this next step. So that would be, I mean, I could factor out more, but I'm just going to factor out an h. h times 64 plus 16h. So factor out the h from the top, and then it cancels with the h in the bottom. So then what do we have? We just have 64 plus 16h. Now if h is really, really tiny, suppose h is 0.00001. If we did that, 0.00001 times 64, times 60, oh no, sorry, times 16. 0.00001 times 16. I don't know if I did the correct number of zeros, but I get 0.00016 or whatever. So really, it's pretty much just 64. So the instantaneous speed, if you suppose that h is just really, really tiny, it's going towards 0, then it would be 64 feet per second. So we can say feet per second. All right, that's enough for this. It's got longer than I imagined, but cool. That's average speed relating to instantaneous speed. You just use the average speed formula and add something that's a tiny, tiny amount. That introduces the idea of the element.